And in this problem, you selected answer A, which is not correct. And the reason is that we see there are two factors that are shown here. One is that we achieve a relatively high conversion of 70%. And we also have a minimal pressure drop, so we maintain a high overall pressure in the reactor. If we look at our instantaneous selectivity of the desired to the undesired product, we're going to expect that that's equal to the rate of the unimolecular reaction, which is first order in A, divided by the rate for the undesired reaction, which is second order in A. And so the instantaneous selectivity is going to be equal to this ratio of rate constants times the concentration of A to the negative first power. So in other words, as the concentration of A increases, the selectivity to the desired product is going to decrease. If we're going to try to maximize the selectivity to D, then we want to try to decrease the concentration of A in the reactor on average. Okay, one effect that will decrease the concentration of A, our reactant, is to operate our overall reactor at higher conversion. So the higher we go in conversion in this reactor, the lower the amount of reactant will be that's left in the reactor at the end. And so the instantaneous selectivity, therefore, will start to become larger toward the desired product. And so in other words, if we express the concentration of our reactant A as a mole fraction times the pressure in the reactor over RT, right, assuming ideal gas behavior, then as we get higher conversion of A, the mole fraction of A is going to go down throughout the reactor. And so that's going to tend to decrease the concentration of A and improve our selectivity for formation of the desired product. Right, however, we can see that in the case of reactor A, we actually have a minimal pressure drop. Right, and so that means that we're going to be keeping this pressure high, which is going to tend to keep the concentration of A high. And so we don't expect that this is the optimal case for maximizing the selectivity to D. And so in this case, please select another answer that you think could be a correct solution to this problem.